All righty. Yes, because it disappeared for some reason. I thought it was wanting me to shut down. There we are. Okay, function notation. Draw. Okay. What does every function have? Pardon? It has numbers. Excellent. It has more than one variable, usually. But yes, it must have a variable. Usually, variables. What else? Antonio. I understand what you're saying. I'm just trying to... Yes, I agree with what you're saying, but there doesn't necessarily need to be an X, right? But I need more general than that. What Antonio is saying is something is going to multiply one of those variables. Well, I mean, it needs an operation of some kind. Because it doesn't necessarily need to be multiplication. So I need all of those things, yes? The numbers are all constants and coefficients. The variables are all IV, DV, and all of their names. Okay? So sometimes we'll use input, output. And I'm going to keep these in the same order. Right? And the operations are any math. So add, subtract, or multiply, add, subtract, divide, square root, square, anything like that. All those things need to be there, yes? And how do we write a function? How have we written every function we have discussed this semester? Generally speaking. What is usually isolated? Which variable? The dv or the iv? The dv. So most functions look like this. dv equals iv and some math. Right? Everybody cool with that? Now we could also write this as output equals our input, to which we apply some math. How have we been writing it with letters? Just use y and x. Y is output or is x output? Y equals x with some math. That is review. We are all comfortable with that, yes? Right? Okay. So here I have what may or may not be a function. Now when you look at that, you should all automatically know that's a function, right? Why? What about just looking at that lets you know that it's going to graph a straight line, a linear function? Antonio. As numbers, variables, coefficients. Excellent. So we're going to be able to graph it because there's two variables, yes? We're going to be able to make x and y happen, okay? What about that makes us know it's going to be a linear function, a nice straight line? There's no exponents, right? Now, on the right, I've given you a chart. That chart has 4 numbers on it. Those 4 numbers are x's, which means those 4 numbers are what? Inputs. Because they are inputs, who chose them? Somebody. Did it matter what numbers they chose? No. There is no right numbers to choose for input at all. Choose anything. Those are the numbers that are chosen. Since those numbers are x's, where do they go in this function? They go everywhere you see an x. Everywhere you see an x. What if there's more than one x? Then you put the input in everywhere you see an x. Okay? What if there's 17 x's? Then you put the number -2 in the equation 17 times. Do I make myself clear? Because it is an input. It must be input into the equation. When do I get my output? Pardon me? Solved. Yes. When I apply the math to the input. Yes? So, what is 1/2 of -2? Please don't all look at me blankly. You all know how to divide -2 in half. What kind of one? -1. I didn't hear the negative. And what is -1 minus 2? -3. So what is my output? -3. Does everybody understand? Of course you do. Now what goes into the equation? 0. So what is the output? -2. Now what goes into the equation? 1. What is the output? -2.5. There you go. I didn't want to have to write for too much longer. And 4? 0. Everybody good? Everybody understands that, yes? Okay. So this input also gives me values in my domain. Yes? Because the domain is all the x values. Now, this particular function, what are my options for what I put in for x? Every single number. Because no matter what the number is, can I cut it in half? Yes. Can I then subtract 2 from that answer? Yes. So my domain must be everything. Agreed? All right. My range. What is my range? Because these, of course, are all outputs, which means these are all values in my range. What's my range going to be? Everything, right? Okay. So now, let's take this thing and let's graph it. Now, I don't want graph paper. I don't need graph paper. I just need a sketch. So give yourself a plane. Now, what would be the smartest way to graph this? You'd use the biggest and the smallest number? Okay? Okay, that's one way you could do it, absolutely. I would use my where x is 0 and where y is 0. Because where x is 0, y is negative 2. So I'm going to go ahead and sketch that in. There is 0, negative 2. Does everyone agree? And out here is 4, 0. Right? Now, can I connect this line? These dots. Is it discrete or continuous data? Of course it's continuous because every single input is available, yes? And every single input can be put in, cut in half, and have 2 subtracted from it. So I draw this line, which will go to infinity in both directions. Does everybody understand that? That is all really grade 9 work, yes? The only thing that has been added in grade 10 is domain and range, and possibly the terms input and output. Although those aren't really, because in grade 6, when you first learned about functions, you may not have called them functions, but many of you heard the terms input and output. So is everyone cool with that? There's nothing new there, is there? But the name of this section is function notation, isn't it? Which means there must be something new, because I have not taught you function notation yet. So function notation is simply this. The y, which is our output, is written this way. F x. And that stands for function of x. We read it as f of x. All right? So instead of a y, we have this here now. Okay? F is simply the function's name. Like I am Myers. The teacher in that room next door is DeVries. So f is this function. Some other function might be called g. Do you understand? Everybody good? Okay. This, oops, I wanted to change the color. This is still my input. Okay? Is everybody good? And I'm going to show you what I mean in the very next question. All right? Now, there's a typo on the next question. The next question, this j should be an x. So please make it so. Yours is x? Good. I'm glad yours is proper. Everybody good with that? Okay. So now, yesterday we wrote functions this way. Y equals 2x minus 7. Right? And we made the chart like this. X and y. Everybody cool? And we chose the inputs, right? And we wrote them right here. And I told you good inputs to choose are something negative, 0, and something positive. Right? Right? Okay. That was yesterday. Now we write it this way. Remember, this is our output. So now, in function notation, this becomes f of x equals 2x minus 7. Our output is now this. So what does our chart look like? It can't be x and y. It's x and what? F of x. That's the only difference. Do you all understand that? Okay. Now, look at that. How would you read that in English? When it was fx, we read f of x. So what am I going to read that as? F of 2. So the f of 2. Now, you guys are smart kids. What letter, 1 second, I need to do something here. What letter is that? X, excellent. What number is that? What did that 2 replace? X. So what replaces that X here? 2 minus 7. So what goes in our first spot in our chart? 2, because the input that we are given is 2. Does everybody understand? It's exactly the same, except instead of a y, we write f of x, or g of x, or h of x, or I of x, or q of x. Does everyone get that? It is not boggling any of your minds. Because every year this boggles minds, and I don't know why. I don't know why. Oh my God. Why? Because this has replaced y. So I don't know why this boggles your minds. What's the output? What's the output? He waited for 30 grade 10s to do 2 times 2 minus 7. -3. Lovely. So this gives me a point on the graph, yes? What would that point on the graph be? 2, -3. And on a graph, we're back to x and y. Everybody good? All right. What's the next one? F of what? -3. So the x was now replaced by a -3. So what's my function look like? Because the question gave us that input of -3. So what? 2, -3 minus 7. What's the answer? He waited patiently. There's no trick here, guys. It's 2 times -3 and then take away 7. Maybe I should hear the clicking of more calculators if this is too complicated. I got coffee to drink and I got negative. Thank you. That was a poser. So what was my input? -3. And what was my output? -13. All right. Now I'm going to do something different. Now my f is 2x. What? What did I replace x with? 2x. So what do I replace x with in the question? 2x. So what's my output? No. 4x minus 7. I cannot do any more. The point I'm trying to make is whatever goes here goes in there, no matter what. What if I wanted the f? I'll change color one more time. What if I wanted the f of lightning bolt? It would be 2 lightning bolts minus 7. Do you understand? What if I wanted the f of $? What would it be? 2 $sign minus 7. What if I wanted the f of the peace sign? 2 peace signs minus 7. Do you understand? No matter what is in those brackets, it goes in for x. Do you get it? When it's numbers, it's easy. When it's not numbers, it's still easy. Because all you do is rewrite it. Okay? Everybody good? Yeah, all right. Let's move it along. Let's look at the next one. Uh-oh. The next one has a new name. Does it matter? No. If I got married to a powerful woman who insisted I change my name to her name and I loved her to death, and I walked in here one day and I said, my name is now Mr. Jehoshaphat, would you still do math? Yeah, because it doesn't matter what my name is. You follow the same rules. So this is G of X. This is F's ugly cousin that comes to the wedding, and you're expected to dance with them because nobody else will. That's happened to every one of you, I am sure. Go dance with your cousin. Nobody will talk to him. That's because he's weird. Don't say that. He's your cousin. I don't care. All right. Output function. What is my first input? G of 6. So, negative 2/3. What do I write instead of X? 6 plus 1. What is my output? Well, that's negative 12 over 3, yes? Which is negative 4 plus 1, which is negative 3. So what is the point on the graph that I get from here? 6, negative 3. Does everybody see why? The X became a 6. X became 6. Became the point on the graph. Output, G of X, because that whole thing is my output, became 3, so that became my Y value. Does everyone understand? Good. Do the next one. What's my second input? Read the question. What's my second input? G of negative 3. So I write it out as negative 2/3, negative 3 plus 1. The 3's are going to cancel, aren't they? The negatives are going to cancel, aren't they? Giving me 2 plus 1, which is what? 3, yes? So what is this point on the graph? Negative 3 was my X, or my input, and what was my output? Positive 3. Yay! And what is my third input? 0. So that is negative 2/3 times 0 plus 1. What's the answer? 1. What is the point on the graph? 0, 1. Now graph it. Why did I have to do 3 points? That's the only way to know if it's a straight line, right? Okay, so first point, 6. 1, 2, 3, 4, 5, 6. Up, 1, 2, 3. Sorry, thank you. Down 3. 1, 2, 3. Next point, negative 3. 1, 2, 3. Up 3. 1, 2, 3. Third point, 0, up 1. Looks like I went 1 too far there, doesn't it? 1, 2, 3, 4, 5, 6. 1, 2, 3. There we go. And then I connect the line. Why do I connect the line? Because it's a linear function. Can I put any number in for x? Multiply it by 2/3 and then add 1. Yes. Is everybody good? Everyone is good? Nothing new, right? Just a slightly new way of writing it. Everyone's okay? All right. Now the next one is where the wheels start to fall off. Read that question. I'll rewrite the function. It's g of x equals negative 2/3 x plus 1. I have this. Where does that go in this equation? No, you can't answer, Antonio, because I know you know. I need somebody else to figure this out. I'm sorry. It's a dick move, but I have to know if one of the other 26 kids, because I'm not even counting you two, can figure this out. What letter, Sammy, is that? Is any number written there? Is any number written there? Or is it still a letter? Still a letter, right? Does this look different than this? Look closely at the two things that are highlighted on the screen. You're telling me they look the same. This is g of 0. This is g of x. This is not, this x is still x, right? Which means if that's x, what goes in for x here? X. But I still have equals 7. What do you see here? G of x. What is the g of x? 7. So what goes in here? 7. What happens to x? What is x? What? Still x. So it's negative 2/3 x plus 1. There you go. So what do I do with that? My grade 9 math students who know how to do algebra because they were in my class and we spent forever on it. I'm not looking at anyone in particular, but I might be looking at somebody who was in my class for a long time and who was actually pretty good at equations. Yeah, you were. I isolate the variable. So I better get rid of that plus 1, right? Right. Minus 1, minus 1. Now I've got 6 equals negative 2/3 x. Now what do I got to get rid of? You could divide by negative 2/3, but most people in Canada cannot do that in their head at all. Most people in Canada can't even do that with a calculator. So we're going to go step by step. I got to get rid of divided by 3, don't I? So I multiply by 3 to get 18 equals negative 2x. Yes? Now what do I do? Add? Minus? There we go. Divide by negative 2. And x equals negative 9. Now, the $1,000,000 question. What is the point on the graph from this work? Negative 9 and 7. Because x is negative 9 and my output was 7. This is where the wheels fall off. Are they going to fall off for you? If this is a number, it goes into the equation. If this is a letter, that's your answer, and you have to find what we put into the equation. Does everybody get it? Let us see if indeed you do. Here is a new function, m of x, named for me, because I'm Matt. What do? I look and I see I have an m of 7, I see I have an m of 1, and I see I have an m of x. does it matter which one I do first? Yes or no? Do you think it matters? No, of course not. I'm going to go in order. The first one was m of 1. Did that x change to a number? Yes. So does that x change to a number? Yes. What number does that x change to? 1. So I have 4/3 times 1 plus 2. Right? Right? Okay. What is 4/3 times 1? 4/3. Plus, can I add 2 to 4/3? Of course I can. It's 2 and 4/3. But 2 and 4/3 isn't a real thing. We don't write that, do we? 2 and 4/3 would actually be 3 and 1/3, wouldn't it? I must restart my computer. No, I mustn't. You're not the boss of me. Is everybody okay with that? Yes? So what is the point on the graph? 1, 3 1/3. Yeah. Next, my m is now 7. Did that x change to a number? So what do I put in the equation? 7. That's going to get me 28/3 plus 2. That's a little harder to add, isn't it? Well, 28/3 is what? 8 and... Is it 8? It's 9. And 1/3. 9 and 1/3 plus 2. What's that? $11 and 1/3. Yes! 30 of you and 1 of you can add 9 plus 2. Spectacular. What's the point on the graph? And 11 and 1/3. And what is the third thing I have? M of x equals 5. Did that x change? No, it's still an x. So what happens to the equation? It stays as x. But m of x is 5. So what goes over here? 5. And what do we do with that? Solve it. How? First, I take away 2. 3 equals 4/3 x. Then what? You could divide 3 by 4/3, right? Right? I, of course, would not do that in my head. I would multiply by 3 first to cancel the 3's. 9 equals 4x. And then what? Divide by 4, and 9/4 would equal x. Correct? Now, what is that point on the graph? 9/4, which is 2 1/4. And 5. Yay! And now we could graph that, yes? Everyone is Gouda? Okay. You guys do that exact same thing by yourselves with number 6. Okay? Go. The first one is h of 2. So I want the h of 2. X became 2, so negative 1/4. What goes for x? 2 minus 4. That's negative 2/4 minus 4, which is negative 1/2 minus 4, which is, negative 4.5. Is everyone okay? What is the point on the graph? 2, negative 4.5. Now I need the h of negative 2. Negative 1/4 times negative 2 minus 4 becomes positive 1/2 minus 4, which becomes negative 3.5, giving me a point on the graph of negative 2, negative 3.5. And finally, h of x equals negative 4. So I have negative 4 equals negative 1/4 x minus 4. Plus 4 to both sides. 0 equals negative 1/4 x. So x equals 0. And the point on the graph is 0, negative 4. Is everyone okay? Now, I know I was mean and I put fractions in here. But it wouldn't matter, would it? If it was 2, you would just do the math. Okay? Okay. Turn the page over. You can go back and watch this online if you need to, even though half of it just disappeared. So everything we've done up until now has been algebraic in nature, yes? We've used algebra to do this. But you are all aware that you can draw a picture of any function on a graph, can't you? Well, here we have 2 functions. The curvy one is f of x. The straight one is g of x. Everybody cool? All right. I want the f of negative 3, which means which function am I dealing with? F of x or g of x? F of x. So I need f of x. But I don't need the f of x. I need the f of what input? Negative 3. Where do I find on a graph my inputs? X's or Y's? X's. So where do I go on this graph to find the f of negative 3? My input is negative 3. Where do I go? I go out to negative 3, right? Right here. That's my input. Where do I find my output? The y value that is on the line that I am looking at. I am looking at the curvy line, so I find the y value. Does everybody understand? So what is the answer to A? Negative 2. Does everyone get it? Okay, I'm going to use blue for this one. G of O, 0, not O. So I'm looking on the g of x function. But I need my input of what? 0. So I go to what spot on the x-axis? 0. And I find the output on which line? The g of x line, the straight line, or the curvy line? the straight line because I'm dealing with g. So I go up, and what do I find? 2. So what is the g of 0? 2. Is everybody good? Yes? Okay. Now, you guys find the f of negative 2. Remember, that means we are looking on the f of x function. Where do I go? I will be doing this one in green. When you think you have it, touch your nose. Wait, sorry. Simon says touch your nose. I don't want you all to be out. And don't do that thing where you do this and touch your nose with your middle finger, because I know that move. Okay? I invented that move. So now that I see a lot of noses being touched, I am just going to say, so nobody feels that they are inferior to their peers, I go to 2, because that was my input, negative 2, and then I find the output, which is right there, which is negative 3. Now applaud with your nose, if you did it right, Simon says. Okay. In D, do I have an input or an output in the question? I have an output. So would I start looking on the x-axis or on the y-axis? On the y-axis. Why? Because that's where the outputs live. So I need to go on the f function to positive 1 on the y-axis. Does everybody understand that? So I'm going to erase all these other lines and dots so it doesn't get confusing. Here, and I'll work this one in red, I go to 1 on the y-axis. Oh, the line goes right through that. What is my x value? 0. Does everybody see why it's different? Why it's different. Okay. Now with this one, where do I go? To what 3 do I go? An x or a y? You just said both, Sammy. Which is it? Exactly. Because this is an output, yes? So I go up to 3, and I find the x value where the line hits 3. Right there. What is that x value? Negative 1. Yes! And finally, you guys do the last one by yourselves. Do you go to x or y? Then tell me the output on the right line. Negative 2. Exactly. Because you went out here to 4. And then you went down and you found negative 2. Why could you? Yay! Okay. I'm going to take a risk because today has been a little bit difficult. What with those complicated questions like 9 minus 2. Okay, here we go. On all your blank space, the f of x equals 2x plus 1. Everybody okay? Write this down, please. The g of x equals 3x minus 4. Is everybody okay? I want you to tell me the g of the f of 2.
What?
WTF? You stupid. Where do you think you could start? Why, Cassie? Pardon? Abresia, why? I could find f of 2, couldn't I? So where does that go? In the blue x or the red x? The blue x. So the first thing I must do is the f of 2. What is that? 2, what goes here? 2 plus 1. What is 2 times 2? Plus 1, 5. So the f of 2 equals 5. Do you see the f of 2 somewhere? Right here. So what do I put there instead of f of 2? 5. So now I need the g of 5. Is there a g function here? My gravy, there is. But it's not g of x, it's the g of 5. So what do I put in for that x? 5 minus 4. What is 3 times 5 minus 4? 11. Wait for it. I have now been given 2 different points on a graph. What is the first point from the graph? 2 and 5. 2 and 5. What is the second point from the graph? 5 and 11. They get it.